Welcome to REDOX video, people. This will be the first reaction that we take a look at today. Go ahead and pause and write it down. As we know, the redox reaction is a reaction that we can identify by a free element reacting. So right away in my first example here of calcium reacting with hydrochloric acid to produce calcium chloride and hydrogen, I know it's redox just by looking at the reactants. I don't even need to look at the products. But as soon as I see calcium there all by himself, I know that it's not neutralization, so no acid and water being made. I know that it's not precipitation, so I don't need to identify solid or aqueous for the solubilities of the products. Instead, redox has a different thing that you need to do. But here's some good news. At this level in chemistry, we don't make you predict the products of a redox. In other words, for redox, I will never just give you the reactants and have you come up with the products. You could do it. There's a thing called an activity series that helps you know when things will swap and where they'll go. But we don't do that in general chemistry 1. So for a redox reaction, you'll get both sides. But what we need to do is look at some vocab on why this is called redox. If you take a look at your cheat sheet on the part where it says redox reactions, you'll see some vocabulary there. Redox is actually 2 words put together, reduction and oxidation. And what happens during these reactions is there's electrons that are moved around. Some guys, elements, receive electrons, and those guys are reduced. They become more negative, where other elements get rid of electrons and they become oxidized and become more positive. Now that vocab I just said will certainly be vocab questions that are on your test, but the definitions are on your cheat sheet. But again, an element that is reduced has gained electrons and become more negative. An element that's oxidized has gotten rid of electrons and become more positive. Our job in a redox reaction is to label which is which. What element was oxidized? What element was reduced? And there'll be an element that didn't change his electrons. One thing I want to draw your attention to is the number line that's on your cheat sheet. I'll draw it up here, but the number line will help you quite a bit for those of you that have trouble keeping negative charges in mind. I do want to note that even though some of you will like using the number line for today's skill, I won't give it to you on the test. You can still get it on the test. When you get your scratch paper, just write it down right away, not while it's in front of you, but it needs to be out of your brain. But anyhow, you can recreate the number line, but you'll see how it's useful for what we're about to do now. So in your notes, work along with me. Here's our first redox reaction. What I'm going to do is list the elements the way I would if I was balancing. We're not balancing, but we've got calcium, hydrogen, and chlorine. So go ahead and list those with me. In order to figure out who was reduced and who was oxidized in my redox reaction, I need to compare the charges of the reactants to the charges of the products. So it's important that you have your periodic table out with all the charges and your polyatomic list with all the charges. Of course, those will be given to you on the test. And we can start labeling some stuff. But there's a new rule. Look here. You know how to find the charges of things. If it's an element by itself, you just look at the top of his group. It'll have a +1 or a -3 or something up there. If it's a polyatomic, the list tells you, but there's a new rule. Free elements, like calcium there, you've never been asked the charge of a free element. The only question that we've ever asked about a free element is it diatomic? You never have looked at the charge of an element that's unbonded. A free element has a charge of 0. all free elements, no matter what they are. Anytime an element's not in a compound, his charge is 0. What we need to do is identify all the charges on the left first. Calcium is a free element. All free elements have a charge of 0. But compounds have the charges that you're used to them having. Go find hydrogen on the periodic table. Go find him, go find him, go find him, go find him, go find him. He's in a compound. What's hydrogen's charge? But not just 1. What's his charge? +1. Does everybody see where I'm getting +1 from for hydrogen? It's above his group. Chlorine is in a compound, which means his charge is correct. What's chlorine's charge on the PT? It's -1. Now, what we've done so far is identify the charges of everything on the reactant side. We want to compare that to their charges on the product side, because you'll see that some of them change. Is that calcium in a compound? He is. So what's calcium's charge when he's in a compound? Don't just say 2. We're not crisscrossing numbers for subscripts anymore. I need the charge. What is it? +2. Because calcium's group, the alkaline earth metals, have an oxidation state of +2. What about hydrogen? I'm sorry. Going down my list here, hydrogen's my next guy. Look at hydrogen there. Look at him. 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 What's that hydrogen's charge? It's 0. Because all free elements have a charge of 0. He's all by himself on this side. He's not in a compound. Therefore, his oxidation state is 0 when he's alone. Chlorine is right there. Chlorine is in a compound. What's chlorine's oxidation state? -1. Chlorine, group 17. All right, just put your finger on chlorine, run it up. There should be a -1 written up there. Now, we're able to do our final step. Again, in a redox reaction where there's free elements, our job is to identify what was reduced and what was oxidized. By looking at the comparison of numbers, we can figure this out. Now, you can either memorize the definitions, that reduction means you become more negative, and whichever number became more negative would be reduction. Or we can learn to use the number line. You'll see that on your cheat sheet, it's got arrows that tell you if you go that way, you're oxidized, and if you go this way, you're reduced. Let's take a look at what these numbers did. Calcium went from 0 to +2. Look at my number line. Calcium went from 0 to +2. What direction did he go? The reduction direction or the oxidation direction? He was oxidized. Calcium was oxidized because he became more positive. He lost electrons. Let's take a look at hydrogen. Hydrogen went from +1 to 0. Watch. He went from +1 to 0. Did he go the oxidized or reduced way? Reduced. Hydrogen was reduced. The definition of reduced is to become more negative. He went the negative direction. Or to gain electrons. You will want to know those definitions along with your number line. What did chlorine do? Nothing. A lot of times, there will be one element unchanged. Let's do another one. Next example. Hydrogen reacts with fluorine to produce hydrofluoric acid. I know it's oxidation because there's a free element right there. As soon as you find a free element, it's oxidation. Redox. So my one job during redox is to identify what was reduced and what was oxidized. I'm going to make a list of elements. This one only has 2. And now we want to identify the charges on the reactants versus the charges on the products. Help me out. What's the charge of this hydrogen? It's 0. He's a free element. All free elements have an oxidation state of 0. What's fluorine's charge here? Also 0. All right, neither of them are in a compound. So both of them have predicted charges of 0. But on the product side, they are in a compound. So now the periodic table will help us. What's hydrogen's predicted charge? Right there, +1. What's fluorine's predicted charge? Right above fluorine, -1. Hydrogen went from a 0 to a +1. Therefore, he was oxidized. Fluorine went from a 0 to a -1, so he was reduced. The REDOX. Let's do another one. Iron reacts with lithium hydroxide to produce iron 2 hydroxide and lithium. It's redox because iron is by himself. So I make my list to identify what was reduced and what was oxidized. I see iron, lithium, and hydroxide. When you see a polyatomic ion, keep it, it's easiest to group them together in your list. What's the charge of this iron on my reactant side? 0. He's all by himself. Don't mess that up. What's the charge of lithium in a compound? Lithium on your periodic table is +1. What's the charge of hydroxide in a compound? Check the polyatomic list. -1. All right, if you look at hydroxide, he's -1. Let's check our products. Careful on this one. What's iron's charge here? Not just 2, +2. All right, remember, all of the transition metals are cations. They're all positive. And what number did iron give to hydroxide? A 2. Now, even if you didn't know it was +2, as long as you knew it was plus something, you would still get the right red or ox answer. So just remember that all transition metals, they're always positive. Lithium, what's lithium's charge here? 0. He's a free element. All free elements have a charge of 0. What is hydroxide's charge here? Still -1. He's still in a compound. And hydroxide's charge in a compound is -1. Now, realize there's another way I can ask you this next slew of questions. It'll get you to the same answer. But did iron gain or lose electrons? To become positive, you must lose electrons. You must get rid of your negatives if you're going to become positive. By definition, losing electrons is oxidation. Now, you can verify with your number line 0 to +2, it's oxidation. But realize I can ask you the vocabulary version of that question. All right? Did lithium gain or lose electrons? He became more negative. He went from positive down to 0. He lost the positive. The only way to do that is to gain the negatives. We're talking about negative particles. So lithium gained electrons, and by definition, gaining electrons is reduction. This vocab stuff is on your cheat sheet. Monkey grapefruit, right? Or +1 to 0 is reduction. All right, and hydroxide didn't change. You try one and we will call it a unit. It's redox because of a free element. Only during a redox reaction do you do what we're doing today. I hope it's obvious that each of the different three have a water salt thing that happens, a solubility chart thing that happens for precipitation, and then a REDOX thing that happens for redox. Hydrogen, bromine, and magnesium is what we're dealing with here. My compound, this is +1, -1, if you check where they are. So +1, -1. Magnesium has a charge of +2 on the table, but it doesn't matter here. He's a free element. All free elements have a charge of 0. Here's a compound. So it's +2 -1, +2 -1. If I put them in all the right places. Hydrogen usually has a +1 according to the table, but he's a free element there. All free elements are 0. To analyze, if I go from +1 to 0, +1 to 0, I have moved my finger in the reduction direction. Bromine went from -1 to -1. He didn't do anything. Magnesium went from 0 to +2. He went in the oxidation direction. Anybody get different answers? We've got lab tomorrow.